What's cracking, J-Coders? I'm J-Coding, and today we're going to be learning about if and else statements in C. If you guys don't know what an if statement is, essentially the programmer is able to give the computer a conditional statement. So let's say I have two variables, int x and int y, and we want to find a way to compare these two. So what we do is we call this if statement simply by typing if and opening up the parentheses. Now what the computer reads is whatever is inside these parentheses, and we have to compare these values somehow. So let's compare them. Let's say if these values are equal, we want to print out these values are equal. And in the event that they're not equal, we give the computer a different condition that says else. There are only two possible outcomes in this scenario. Either the numbers are equal or the numbers are not equal. So it is assumed that since this did not pass, you don't need to write an additional argument after the else here. It's just assumed that x is not equal to y. What do we want to print? We want to print these values are not equal. So the last thing we want to do is we want to actually give values to x and y. So if we set them both equal to 3, let's see what happens. It says these values are not equal. So just to go over exactly what happened right here, the computer read from top to bottom, right? It sees that we made two variables, int x and int y, and it makes space in the computer to store the numbers 3 in both of those spaces. And then it uses our comparison tools, the if and else statement. And we are essentially saying to the computer, if x is equal to y, and this is how we say is equal to, we just use a double equal to sign. And we said if x is equal to y, we want to print out that these values are equal. And in any other case, and in this case the only other case, is that x is not equal to y, we print these values are not equal. Well, let's see if we change y from 3 to 4 and rerun it. It says these values are not equal. Simple enough. But what if you want to compare multiple numbers? What if you want to compare two sets of numbers, right? Let's make a z and a. If int a is equal to 4 and int z is equal to 4, and for the sake of this example, we'll change y back to 3, and we want to do an even greater comparison. So let's say if x is equal to y, we want to use another way to compare even larger sets of data, where we can use and, using a double ampersand. And a is equal to z. So in the case that x is equal to y and a is equal to z, print these values are equal. In the case, sorry, I forgot a semicolon there. In the case that these two sets are not equal to each other, it prints out these values are not equal. So because 3 is equal to 3 and 4 is equal to 4, it prints out these values are equal. Just so you guys understand how the AND operator works, we'll change this to a 4 again and rerun it. And it says these values are not equal. Because what the computer does whenever it sees an ampersand means that every single condition that's given must be true. It's as if you were speaking to an actual person in real life. If you say to the person, I want apples and oranges, and they only give you oranges, well then they didn't complete the task. In this case, it's the same way. We're saying to the computer, if x is equal to y and a is equal to z, these values are not equal. But in the case that either one of them are not true, the whole if statement becomes untrue, and it goes straight to the else. Let's go to another comparison operator called the OR. The OR is represented using two straight lines just like that. So now this is read as if x is equal to y or a is equal to z, these values are not equal. So let's run this and see what happens. These values are indeed equal. So let's get into some more comparison operators. So you can do many things with this. You can also do, instead of equal to, you can say not equal to. And the way we denote not is by using an exclamation point. So let's say we change x to 3, y to 4, a to 5, and z to 6. And we go back to our AND example. So the way this is read, if x is not equal to y and a is not equal to z, meaning both the x and y pair have to be different and the a and z pair have to be different in order for this statement to be considered a truthful statement and for this to be printed out. In the case that one of these are equal, one of these pairs are equal, it'll print out these values are not equal. Well, actually, for the sake of this, I should probably switch these statements. Let's run this. These values are not equal, meaning that these are both truthful statements and it prints out exactly how we want. Now let's get into some greater than, less than, greater than or equal to, less than or equal to. It works just about how you would expect it to work. So if x is 3 and y is 4, if x is less than y and a is less than z, we can just say that the case was passed. And over here we can say that the case wasn't passed. So if we run this, it says that the case was passed, because indeed 3 is less than 4 and 5 is less than 6. But what if we changed a is less than z to a is greater than z? What happens? It says that the case was not passed because 5 is obviously less than 6, and we know that and has to have both arguments be true in order for it to pass through. And since this right statement over here is not true, the ampersand does not let this whole statement become true. Therefore, it goes to the else, and the case was not passed. So the same thing with less than, we can do less than or equal to, greater than or equal to. It works just how it would in math class. You run this and it says that the case was not passed. So the last thing I want to go over today are else-if statements. So for else-if, it simply goes as follows. Let's say you have a secondary condition. Let's say else-if. And let's say we are checking for grade. So let's delete all these variables and say int grade is equal to 80. So let's say someone got an 80% on the test, and we're getting a bunch of red lines because it doesn't understand what we're going to try to print out. And let's say there's only 3 grades that you can get. Either you get an A, a C, or an F. So what we can say is, if grade is greater than or equal to a 90, we print out you get an A. Else if grade is greater than or equal to a 70 and grade is less than a 90, we want to say you get a B. Now you guys might be wondering, can we just do the same thing in math class where we do if grade is greater than 70 and grade is less than 90 and put that all into one single statement? The answer to that is no, you can't do that. Computers, unfortunately, aren't smart enough to understand that. So this is what we have to stick with. And when we get to the else statement over here, we actually still don't need to put anything, because if the grade is not greater than or equal to 90, or if it's not in between 70 and 90, then obviously it is less than 70, so it is 69 or less. Nice. So we say you get an F. Oh, and I said the only grade was a C over here. So if we print this out, we should expect a C. It says you get a C. Now if we change this to, let's say 90, we'll try some edge cases. And an edge case means we're going to be testing whether or not they're equal to, basically the top and bottom cases, to make sure the full spectrum of our if and else statements work. So it says you get an A, so that worked. Now if we change this to, let's say, a 50, we get an F. And let's end this on the best number that could be, a 69. Nice. You get an F, but hey, you got a 69, so who really wins? So that's all I have for you guys in today's video. I hope you guys enjoyed. If you did, be sure to leave a like. Let me know what you guys thought of the video in the comment section below. If you or anybody you know is trying to learn C programming, link them to my videos, link them to my channel. I appreciate all you guys' support. Peace.